Okay, working with radical numbers. So how to multiply radical numbers? So if you have a root 7 and a root 3, it's going to make root 21. So root and a root make a total root number of 66. And then this last one, root, do you know your finger method? How to multiply by 9? Put down your 7th finger is 63. Okay, next. Root 5 times root 5 makes a total root of 25. Oh, wait. I can do that. What is the square root of 25? 5. So this one, square root of 7, square root of 7, totals to be the square root of 49. But wait, I recognize that, which is just 7. So can you see what happens? Does that make sense? So here's another thing to think about of why it's happening. Would this be the same thing as writing the square root of 7 squaring, because it's repeating twice? And then what happens to a square root and a square? They would cancel, and then that's how I also end up at 7. Okay, these ones, do you notice how there's now components that are coefficients? Okay, treat them separate. The coefficients, the radicals, they cannot mix. Okay, you can't mix them. Okay, so now, what is the coefficient out of this? 12. 6 times 2 is the coefficient. And what's the final radical number? Root 15. Okay, so again, coefficients can only be the coefficients. So there's a coefficient of 8 here, and then that's all I consider. So 8, root, and what's the root? 18. Okay, breaking down radicals. Okay, so here's what I'm going to do. 90. I'm trying to think of how to divide 90 by my magic square numbers. Okay, your magic square numbers, do you have them all memorized? 1, 4, 9, 16, 25. Those are magic square numbers. So 90 is divisible by 9. So then I'm going to go root 9 times root 10. Would we agree that that still is a root 90? Then what is the square root of 9? 3. Okay, so give me this one. What is 45 divisible by? Do you have any of the perfect numbers that it's divisible by? Is it divisible by 4? 9, 16, 9? 9 times 5 is 45. Therefore, root 9 times root 5 is root 45. What is root 9? Whole number 3, root 5. So this is called a mixed because you can see that I have a kind of a whole number part and a radical part. So that's why it's mixing. Okay, how to work backwards. So this is mixed, and I'm going to take it into a whole. So how did I get a whole number 3? The square root of 9. Okay, so that's how I got that whole number 3. I did a square root of 9 times the square root of 3. And then this is radical radical, so it can be put together in a radical. So then 9 times 3 is 27. Okay, 12. What's the perfect square number you can divide 12 by? It's divisible by 4. So root 4 times root 3. What is the root of 4? 2. So 2 root 3. Okay, 48 is divisible by what perfect square? 8 isn't a perfect square. 8 times 6? Yeah. But can I square root 8? No. Can I square root 6? No. What is it? 4 times 12. I can square root 4. Okay? But I don't want that one because there's another perfect square. A bigger perfect square. What is it? 16 times 3 is 48. Okay? So I want to get the biggest perfect square. So 16 times 3 is 48. And then the root of 16. Okay, so what if somebody didn't pick the biggest one and they picked 4 and 12? Okay, here's what would have happened. So if they picked that, then I would have got a 2 here and a root 12. Okay, but guess what 12 does? It breaks down. I can take a root 4, root 3 out of that. And then, can you grab that, Jacob or Matthew? And then the root of 4 is 2. So look at how I got to the same answer. Okay, I got there, but look at what I had to do. I had to do 2 breakdowns instead of just 1. Okay, so you're always trying to pick the largest thing. Okay, this one is working forward, so how did I get a whole number 5? What would I have needed in my radical to make a 5 there? I would have needed a root 25. And then that totals to be root 50. Okay, 18 is divisible by what kind of perfect square number? 4, 9, 16, 25. 9. 9 times 2 is 18. Okay, so now this is different because there's just a 7 there. I just have to bring it with me. Then the square root of 18 is 9 times 2. So there's a 7 there. The square root of 9 is whole number 3. So now I'm just attaching the 7 to the whole number, the coefficient part. Okay, so that's the only added step in there. Okay, what if I up this to cubics? You got all your cubic numbers in your head? 1, 8, 27, those kinds of numbers, okay? What is 54 divisible by? 8, 27, 27? 27 times 2, right? Okay, so I'm going to break this down into the cubed root of 27 times the cubed root of 2. So I'm just changing my square root to a cube root. And then what is the cubed root of 27? 3 cubed root 2. Okay, the next one is a square root. So back to square root brain. How did I get a whole number 8? The square root of 64. So then the total square root would have started with a 128. Okay, the next question, you're back to cubic brain now. How did I get a 5? The cubed root of, the cubed root of what makes 5? 125. The cubed root of 125 is where the 5 came from. So then the total cube root would have been, somebody know what that is without a calculator, a little bit of mental math. 500. Okay, cube root numbers, 8, 27. What is this one divisible by? 8. So the cubed root of 8, the cubed root of 2 is the same as writing a cube root of 16. And what is the cubed root of 8? That can be done nicely. 2. So the cube root of 8 is how I get a 2 in the front alone as a coefficient. Okay, cube root brain. How did you put a 2 in the front? You would have needed to do a cube root of, the cube root of what is 2? Cube root of 8. And then there was a cube root of 5 after. So the total cubed root of 40. Okay, the last question here is a square. So back to the squaring numbers. So how did you produce a 3? The square root of 9 made the 3 in the front. And then the square root of 5 is after. Oh, we already had that question up top somewhere too. Okay, so this is the last question of the day. Okay, square root brain. So you got your numbers. 4, 9, 16, 25, 36, 49, all those. 98 is divisible by, anybody got a value? Any of those perfect squares that you can divide by? Do I have to offer a candy to see if anybody can think of some perfect square? 16? I guess, no. 49. Who said that? 49. Divisible by 49. 49 times 2 is 98. Okay, so 49 times 2. Okay, but they're radicals, right? Because it's a total root. What should we do with this 6? We can't forget about it, right? Okay, next, what am I going to change the root 49 into? a coefficient 7. There's still a coefficient 6 and a radical 2. So what's my total coefficient? Because those are both coefficients, so they can be put together. Okay, 18. What perfect square do you want to do with 18? 9. So the root of 9 and the root of 2. Do you notice how I'm always writing the perfect squares first? I don't write root 2, root 9. I always do the perfect one first. So 9 is the perfect one. Okay, don't forget to write the coefficient part in the front yet. Okay, now what is the root of 9 going to change into? A 3 coefficient, and then there was a 5 as a coefficient and a 2 as a root. Okay? Again, you can't be mixing, but you can put those together because they're both coefficients. Okay, then you can actually take this one a little further. If I have this many root 2's plus this many more root 2's, you can think, how many root 2's do I have as a total? And that's my final answer. You have 57 of those root 2's.